So here's one of the problems from chapter 12, from 2011, number 5. It's about windmills, and they give you all this information up here about what this study was about. It's about wind velocity and what is it? Electricity production. That's the Y variable. So we're going to jump to the computer output and use it to do as much as we can. In fact, the first part of this is from chapter 3. Parts A, B, and C come from chapter 3, which is very closely related to chapter 12, and then chapter 12 comes in part D. And it doesn't hurt you to mix them a little bit, right? So, equation of the least squares line. Remember, we look for the coefficients, which is right here, and the first one that's next to the constant is the y-intercept, and the slope is next to this. This is the x variable. X is wind velocity, explanatory variable. So I'm going to go y hat equals 0.137 plus 0.0, or not 0.0, but 0.24 x. And then remember they said, actually you really should do this even if they don't say to, but this part about identify all the variables, make sure you label what y is and what x is. X is easy because it says so right there. X is wind velocity. This is what we're using to predict. We're predicting electricity production based on wind velocity. So this is my y, and this is my x. Y hat is the predicted electricity production. I can leave myself a lot of room to write here, a lot. Alright, so then the next question is, how much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles per hour, that's an x value, compared to a day when the wind velocity is 15 miles per hour, another x value. So we're actually going to do, there's two ways to do this. One way is to plug in both x's into the equation and see what happens. Or there might be another way, but actually I kind of like that way best. So we're going to plug in 25. So we're going to look at y hat being 0.137 plus 0.24 times 25 compared to the other y hat, which is 0.137 plus 0.24 times 15, and see how much different it is. And actually, maybe I won't do it this method because now that I'm looking at this, I'm saying this part's the same. So if I subtract them, that part's going to cancel. This one's 10 more than that one. So the difference between these is going to be basically 0.24 times 10. I'm predicting, just doing it in my head, that it's going to be 2.4, but I guess I'll prove it to you by showing you on the calculator. So we have 0.137 plus 0.24 times 25, and then we have 0.137. I guess I could just do this and change that to a 15. And I need the difference between these. How much more would they be expected to produce, the windmills? So I'm going to go 6.137 minus 3.737, and as I told you, it's 2.4. So I'm subtracting these. 2.4. It'd be nice if I knew what the amperes. We expect it to produce 2.4 amps more when the wind is this fast compared to this fast because the difference in the wind is 10. So let's just think about slope for a minute here. If the difference in x is 10, what does the difference in y become? It's 2.4 because 2.4 over 10 is 0.24. So that's my rise and my run. And if you didn't think of that and you just went through the process of this, that's also fine. Alright, what proportion of the variation in electricity? Ooh, that sounds familiar, doesn't it? Don't you think you've heard that phrase somewhere before? This is the variation in y explained by the linear relationship with x. Oh my goodness, that sounds exactly like something we learned. It's actually r squared. So here's a fancy way of asking for r squared. Instead of telling you, please interpret r squared, they give you the interpretation and they say, tell me a number. Okay, fine. So I just need the number. It's r squared. It's 0.873. Or you could write it as 87.3% of the variation in electricity. I mean, all they're doing is seeing if you recognize that sentence and can you find it in the output somewhere. Oh, that's nice. I like it when they ask a question like that. It's like, oh gosh, you should know that. Last but not least, we get to the part about chapter 12, finally. Statistically convincing evidence. Oh gosh. Means we need to do a 4-step test, and I didn't leave myself a lot of room, but I'm going to try. So the good news is they did a lot of it for us with this lovely table up here. So I'm going to do a short version and see if I can squeeze it in here. State, we need a null hypothesis. We want to know, is it related? Is there a relationship between these variables? That's another way of saying, is there a slope? Is the slope significant? The null is that the slope is 0, which means there's no relationship. I'm going to abbreviate so that I can fit this in, between electricity and wind. And then the alternate is that there is a relationship. Theta is not equal to 0. In other words, well, I could even say it's positive, but I'm just going to go with not equal to 0. There is a relationship. Now, they do not give us information about the assumptions. That's very interesting. The plan stage is we're going to do a t-test for slope. And actually, I just realized they did tell us something about the conditions. If you read the paragraph carefully, this sentence is super important right here. The regression model assumptions were checked and determined to be reasonable. Oh my goodness, they checked the conditions for me. I don't have to do it. That's very nice. So I'm going to just say the conditions were checked, given, and I don't have to do them. That's kind of nice, because this is the chapter where it's hard to check, right? It's five different things to check. Crazy. Do. They did the do for me also. Oh my goodness. We have to find t, and t is b minus 0 over SEB, and that's all very nice. I could plug in some numbers and prove that I know the formula, so let's do that. 0.24 is the slope minus 0 over SEB, which remember is right next to the slope, which is 0.019. But if you divide those, you might or might not be surprised to notice that it is this value right here. It is the t value they gave me in the table in the slope row. So this is my t, and my p, I could do a t-CDF of 12.63 and 999, and I need to figure out what df is. Did they say what the sample size was? I don't know. I don't see it. That's funny. I have no idea what df is. Later I'll read the scoring guide and it'll probably say, oh wait, never mind, 25 randomly selected days. So df is 23 because it's it's n minus 2. Okay, so I could do this on my calculator, but I really don't need to because they gave me t also. It's approximately 0. Yes, it's significant. Hurrah, conclude. Since t is approximately 0, it's less than 0.05, which I forgot again to say alpha is 0.05, we reject the null that, what is it? We're rejecting that there's no relationship and concluding there is a relationship. I'm going to skip that part. I'm going to say and conclude there is a relationship between wind and electricity. And I just went into my next problem. I'm sorry. But it's okay. I don't really need that dot plot for the next problem. So there you go. Normally they would give you like a half a page to write all that, and I squished it onto one page, and maybe I shouldn't have. All right, the next video will be about that problem that I just wrote on top of. And that's okay.